Hello everybody and thanks for watching. So this is part 2 of the 4-axis CNC controller build. So I've got everything mounted in the box and I'm about ready to get started wiring. Before just diving off into the wiring, I made a few changes to the box. So I took the fan off. It was basically set to blow air this way. I did verify that the power supplies are pushing air, the fans are exhausting out there. So I'm going to flip the fan over so that it's exhausting, and then I'm moving the wire over to here instead of here because I didn't want it to have any electrical interference with the USB connector there. I just wanted to keep the AC stuff away from over here. I've also gone ahead and grabbed some 12 gauge wire. It's got 4 conductors in it. The only thing that requires me to run this neutral is the fan. Everything else is good for 220 volts. So because of the cooling fan, it not being 220 volts, I'm going to go ahead and run a neutral in here. Other than that, I did find some of these pre-soldered connectors for the actual stepper motors, and they were what I was going to be using anyways. They're just little 4-wire spin-on aviation plugs. And I still have one more to make, so I'll have that on video. But I'm going to go ahead and get to the wiring at this point. Everything's about where I need it to be. I'll just speed this part up. Alright, so my choice for using 12 gauge was because everything combined in here, including the 2 horsepower motor for the mill, I'm looking at just over 15 amps, but less than 20. 12 gauge is rated for 20 amps, so everything should be safe getting fed on my main line, which is SOOW. If you wanted to look that up, that's good for running equipment power. But from here on in, I basically don't have to worry about the current as much. So I can get away with using 14 gauge, and in some cases I'll be using 16 gauge. So right now I'm going to wire up the AC stuff. 14 gauge is just simple, so that's what I'm going to run. I got plenty of it here, so. Okay, so watching me strip wires and screw them all down is going to be a lot of fun, I'm sure, but I'm going to skip over that and just kind of go ahead and explain what's going on. So the screws down here are actually my DC voltage going to the motor drivers. So because they're harder to access, I'm going to go ahead and get the DC connected. I'll basically have a positive and a negative going to each one of these motor drivers. Then I need to run my fan, hook it up to 110 volts, and run 5 volts over to here, as well as 5 volts down to here. So the voltages, I'm using 16 gauge wire to go here because it's only 5.6 amps max, so 16 gauges, I believe it's rated for 10 amps. So I'm going with the smaller wire on these, and then when it comes to the 5 volt stuff, coming out of this power supply, that's for the logic voltage, and that's going to be really low voltage, so I think I've got some 18 gauge wire. So I'm going to go ahead and get all this, all the power supplies connected to the different things, and then when it comes down to wiring up the 5 volt logic stuff, I will check back in with you. Alright, so I got some wires stuffed in here, and I basically just want to go over what's going on with the way I've got the 5 volt feeding the motor drivers and then getting the negative from the communication board. If you look here and you follow these red wires, this is coming from the 5 volt positive of this. Then I've got it jumpered over, and on the other side we've got pulse positive and direction positive. So those two are getting 5 volts directly from the supply, and then they're getting the negative from this board. So when this board sends out its signal, it's sending out basically a signal to ground or signal to common. And what that does is it allows all the voltage to come from here and then to ground out through here. And generally speaking, if this is an option, I like to use it because most communication boards can do a better job grounding than they can supplying the voltage. In this case, it doesn't really matter, so I'm just kind of going with what I normally would do. Other boards and other drivers, depending on the way they wire, you could find out that they want it just the opposite of this, where you're running the common from the supply and then sourcing the voltage from here. So you definitely want to pay attention. Read the manual on your motor drivers, read the manual on your breakout board, read the manual on your communication device. Make sure you've got everything set there, because these motor drivers will run on 5 volt, 12 volt, and 24 volt logic. But if you're running 12 volt or 24 volt, you have to put a pull down or a limit currenting resistor in here. So some things you got to look out for. This is about as easy and basic as it gets of a setup. That's why I like this controller. So I've got 5 volts going there, and then for my pin outs, I'm using, I still have to write these down, but I'm using the pin outs on the breakout board, and you can see those coming in and going to the other 2 pins on each of the motor drivers. These are going to go to the stepper motors. I still got one that I'm going to be soldering up here in a minute, and I think that about covers it. I'm also going to be running, I found this old connector here that I had, so I'll drill another hole in the box and run this in for my emergency stop and potentially some other connectors there. And then I have already gone ahead and put my twist lock connector in here, so that's going to be where the mill actually plugs in for the main motor. Other than that, my fan's hooked up, everything's about done. All I've got left to do is solder up this connector and connect it up, connect up my emergency stop stuff, and this box is ready to start configuring to the computer. Right now I'm working on getting some screen capture software so I don't have to do like I've done in previous videos and just record me in front of the computer. So I'm going to get that all set up and check back in with you. Alright, so before we get started, I just want to show you that these little pins here are set in plastic, so you don't want to set your soldering iron to these for very long. It's really easy to melt them and then they just push right on through. So what I'm going to do is I'm going to go ahead and get the solder on each of the wires and then basically have a little ball of solder at the end so that I can just touch it to it, put my heat on there for a little bit, and let the solder soak into this before it gets too hot. So get started on that. Alright, well, not my proudest work, but must have melted a little bit of the green. Get some electrical tape around that. But good enough, it is going to work. Now to get that through the hole. And if your solder connections were no good, just go ahead and redo them. Alright, so no need on the Band-Aid there because I went ahead and resoldered that connector on, got it connected in. Just one thing I didn't go over before is all these enable pins I am not using. If you don't connect them, its default setting is enabled. If I end up deciding to hook those up later, it's pretty simple. It's just on-off based on pin outputs. You can daisy chain them together or set them up individually, but I want them to be enabled. They don't need to be disabled. If I hit emergency stop, it's going to stop them. So that about does it. I still have one more hole to drill through so that I can connect that emergency stop switch. I think that's it. Well, here's kind of a final view of everything. I've gone ahead and hooked up this connector. I've got my 5 volts going out through it, and then coming back I've hooked up the emergency stop wire. But I'm going to go ahead and leave these two disconnected until I figure out what I'm going to do with them later. So I've made sure that both of, I don't know if they can pick this up in the camera, but both these switches are switched over for 220 volts. Everything's wired up. I still need to go write down what pin numbers I was using for everything on here. That way when I tell the computer what to communicate on it, it knows what's up. So I'm ready to hook up power to the wall here, and I think that's going to be it for this episode. I want to thank everyone for sticking along this far. I'm getting that much closer to having this controller built. After this is just configuring it to the computer, and then on the milling machine I've got to rewire the motor leads to fit these twist connect. But what I was thinking about doing is actually test running this mill and getting everything set up to run on the blue mill there. So I've actually gone ahead and started downloading the software and all of that, and being that the motors use the same connectors, all I have to do is run another switch from that blue mill, and this box can actually run either or mill with Mach 3. Meanwhile, I've still got the Acorn board hooked up on that mill, so it can run the Centroid controller as well. I just have to plug the motors back into the other one. I just wanted to say, for anyone who wants an opportunity to support the channel, I did recently start up a Patreon page. I've got a link on the banner on my YouTube channel page. Check that out. I've already made one post on there to show you kind of what's coming up on my next project. Hope to see you guys over there. Again, thanks for watching, and have a great rest of your day.